Hello everyone, welcome to today's masterclass about Bonsai with Dion Moult. Thank you for joining us today. I'm Josefine Sauti, Product Marketing Manager at Ziggurat. So just a quick overview for those of you who may not know us. So Ziggurat is an online institution with over 20 years of experience in e-learning. We provide master's and postgraduate programs in architecture, engineering, and tech management. And as you can see in this picture, this is an event we had this year. We have a great community of people, of ecosystem of people, of more than 20,000 people from 120 different nationalities. And our mission is to inspire and educate the leaders of tomorrow. And actually today's masterclass is related to one of our programs, the postgraduate program in parametric design with visual programming in BIM. And actually Dion here is professor of this course. It's a 4-month program that starts next month. So if you scan the QR code, you can see more details of this program. We actually have a whole module dedicated to OpenBIM. So you can check more details here. And without further ado, I'll hand it over to you, Dion. So I'll stop sharing my screen and you can start sharing yours.
Okay, so I've just unmuted myself and I'll start sharing my screen. So, hey everybody, my name is Dion. Just a bit of apology. It's actually 1 a.m. in the morning in Sydney right now. So if I sound sleepy or incoherent, I will try my best, but let's see how it goes. So just by way of introduction for myself, my name is Dion. I have a background in architecture. I worked as an architect. I also have a background in software development, and I worked as a software developer. And I currently work for a large construction company. And we do large construction projects around the world. And I also contribute to a project, which will be today's topic here, known as Bonsai. And this is a free open source native IFC authoring platform that I am building together with a group of hundreds of individuals who are building this as a collective effort in the industry. And I think to fully appreciate what all of this is about, I'd like to quickly discuss a little bit about IFC, which is a really important aspect of this tool. So back in the 1990s, when people were looking at BIM, they realized we had this problem that all of the software vendors were describing the built environment in different ways to the computer. So they would describe it in a different way to describe its structural properties versus the distribution systems calculations versus the cost of a building versus the maintenance of a building. All of these used different ways for computers to understand and store and interpret the data. So as a result, all these software vendors came together and said, let's create an international standard for our industry to describe our digital built environment. And this standard, as we know today, is known as IFC, or Industry Foundation Classes. And it's a foundational standard of describing our built environment. And it's one of many open data standards which describe the world that we live in. So you might have heard of others like the BOM model, or Speckle has a basic model as well, or Hyperelements, or Project Haystack and so on, or Brick Schema. But what makes IFC so special is that, firstly, it's an open standard. So the specification is freely available for everybody to look at and see how do computers understand our built world. And most of the other specifications out there are not public, and that's quite and this is what enables us to build tools for ourselves as an industry. So for example, if you use Revit or ArchiCAD, the way Revit describes it is a closed proprietary system that only Autodesk has access to. What also makes it quite unique is that it's an international standard. So it's ISO standardized, and this is really fascinating because what makes a standard successful is the number of people using that standard to do productive things with it. If nobody uses the standard, it's not useful. And that means that a standard not only has to fulfill its technical obligations, but at the same time have a certain amount of political or governance or contractual sway about it. So IFC is inherently quite successful in that regard, in that it has ISO certification, which is a slow, complex procedure. It has many government chapters behind it, and so on. And finally, and one of the most interesting aspects, which you can see over here, is that the industry foundation classes covers a huge number of disciplines. So when we talk about describing the built environment, it's not just creating some 3D geometry and putting some data on that geometry, like saying that this box is a wall and that wall has a fire rating of 2 hours. Like, it's not as simple as that. It's also about describing the semantics of the wall. Like, this is the wall which has layers, and those layers are made out of a certain material, and that material has a certain amount of carbon associated with it, which has a cost associated with it, and that cost is represented using a formula of tax and wastage and a waste factor of such and such, and it's a cost item in a cost schedule, and has a parametric constraint relating it to a construction schedule, which says that it must be constructed at this particular time, and it has a certain resource utilization, which states that you can only have this many riggers available on the job site at this time, and therefore there's a trade-off between cost and time as you build this. And it knows that this is either a maintainable or a non-maintainable asset, which may or may not have telemetry points associated with it, which will be linked to live sensor data. Or it might be attached to analytical geometry, which will have constraints required to do certain simulations for building physics. So as you can see, it's quite elaborate and cross-disciplinary, and that's what makes it quite exciting. And for a long time, IFC was simply used as a simple import-export form, in that you could use your costing tool or you could use your modeling tool, and you could hit the file import or export button, and then you would only get just that little bit of costing or just that little bit of modeling data into an IFC file, and that was that. But around about 5 years ago, this all changed, and there was a project that started in 2011, which is known as IFC OpenShell, which is something for software developers to go and work with IFC. And we realized that IFC was rich enough to describe the built environment, that you didn't need to, that this was almost being misused, or its full capabilities were not realized if you just imported and exported it. So we built a whole new graphical tool that you can now deliver a project completely using IFC from beginning to end. So you're delivering projects across all the disciplines, and you have this central IFC database where you can go and, query your building for insights. So the graphical tool that I'm going to demonstrate today is known as Bonsai. This is what it looks like. It's based off Blender, which is a very widely used 3D modeling suite in the CG industry. It's less widely used in the AEC industry, but with the addition of Bonsai, it's now becoming increasingly relevant. So Bonsai is already used by a lot of people around the world, and it's typically used by two types of users. You have on one end, you have people trying to draw their house or doing a small renovation and small jobs, small architectural firms, small engineering firms, small construction firms, or costs or quantity takeoff firms using it in their daily jobs, or small BIM consultants using it for auditing capabilities. And on the other end, and this is quite interesting, it's also used by extremely large firms. So some of the biggest mega projects in the world are using this. So for example, the most well-known is the Hinkley Point C nuclear power plant in the UK. It's also used in the Victoria Cross train station in Sydney, and a number of other large projects in Sydney. The name escapes me at 1 a.m. in the morning, but there's also a huge bridge in Norway, which used it as well. So, and the reason it's used is because what makes this unique is that, unlike other BIM tools, where what you can do is limited by the buttons you can press, the Blender BIM, this Bonsai tool, it used to be known as Blender BIM, so we just recently changed the name, also comes with a huge amount of scripting capabilities. So this software was designed in such a way so that everything I do can be manipulated via code as well. And so you can build your own BIM tools, and you don't actually even need to use the Blender interface or this Bonsai interface. You can completely build your own systems or servers and automated model processing systems out of it. So sorry, I probably should have mentioned this at the beginning, and it's obvious to me now, but everything here is free and open source. So what that means is that it's built by hundreds of people around the world. You can see the people who have contributed. It's all the code's available on GitHub, so you can see how it works. 1 hour ago, somebody fixed 2 crashes in it, so that's really exciting. We've got about 800 known problems, and this is all the signs of healthy software development of people. You can see there's 13 people who have contributed in the past week, who are building things, and just today we can see here in the number of commits. Yeah, there we go. Yeah, this list which you see here are the number of fixes just today. Okay, cool. Let's see a demo. So I thought I'd demo a couple things. The first is, I guess, let's take a look at an existing project. So I have up here, this is a pretty famous project. This is the Revit sample model exported out to IFC. And this is coming from the use case if you are going to use Bonsai to go and looking at an existing model. So these grids are in the way, so I'll just turn that off. And what you'll notice immediately is that this is far more sophisticated than an average IFC viewer. This shows you things to a great level of detail, right down to how IFC actually works under the hood. So you can see details you may not see in other software. So you can see, for example, this spatial breakdown. I can have a site, a building, many levels, and within them, all of the objects that are within those levels. And I can also go into a number of other tabs here. I have the information about the currently selected objects, so pretty basic stuff at the moment, things like attributes. This is very important, the type of the object. This is something that's often missed in other software. So this is, not just this is a roof, but what type of roof is it? So this is a wall. Great, what type of wall is it? Let's select all the walls that use the same construction type. And these are one of the critical things that sets them apart from just being a simple modeling and classification system. Where is that object located? So everything on level 2, for example, if it's part of any aggregation, so parts and components, and then of course basic properties and quantities. And you can see this model is actually missing quantities, it looks like. But on top of all that, it also shows much more interesting things like any classification systems that it's connected to. So things like uniclass or omniclass. It can show you associated library references or documents. So this being something from Revit, Revit doesn't have this capability. But for example, this could be associated to specification sheets, or ITPs or warranty documents or drawings. So I could click on this wall, for example, or wall type, and immediately click on a link which would bring me to a wall types drawing, for example. And that is one of the really critical uses for operations and maintenance when you are maintaining a facility. But of course, since this model comes from Revit, Revit does not export that particular data or even understand anything about the facility world. But that's where tools like Bonsai comes in. We can now, if we attach some documents to our project, we can actually start to enhance and edit this IFC. So we can go and add a new document over here and start giving the revision of the document that all complies with ISO 19650 and so on. So I think this is really fascinating that many people don't realize that IFCs can be edited, they can be enriched, and you can use it as a native database, not just as a file, but as a database and streamed across the web and so on. So this is all the technologies which are currently being developed right now. You can see things like IFC Git, where you can start to collaborate with people online on working simultaneously on the same IFC project and managing managing conflict resolutions and so on. I'm not entirely sure the technical level of the audience here, but I think it's important to see. Let's take a look at this model here in a bit more detail. We can see all of the assets. You can think of this as a library of object types we have in our model. And so if, for example, I wanted to go and add in a microwave somewhere in the project. Let's just throw it one over there. There we go. I've just added a microwave. I can add in, I guess, this car. And this will tell me in a great level of detail. You can see here, I'm editing the IFC. I'm adding new objects. And each one of these objects is a completely new IFC element with its own properties, its own quantities. It can have its own geometry and relationships. So for example, I can dig into this and see that this car is modeled using a connected face set geometry, whereas this microwave is modeled using advanced B-reps. Whereas if I contrast that to, let's see here, if I draw a slab, for example, you can see this floor, concrete. We'll add a floor somewhere here. This is a profiled floor. So in this case, we're using a profiled extrusion with a certain number of layers that make the buildup of this floor. So if I inspect the geometry type, I can see that's extrusion. So as you can see, it goes into quite a lot of detail about what truly is inside your models. And we can see there's actually 103 materials defined, which is, it shows the quality of the model that people typically produce that they don't realize until they start digging into it and try to query it as a database. So we can see that there's probably not 103 materials used in this model. Similarly, we shouldn't actually have 192 styles or 800 types of profiles. We have a lot of, all these materials are uncategorized. So typically we should be able to break up materials into high impact materials like concrete, steel, aluminum, glass, timber, asphalt, things like that, which have high cost and high carbon impacts versus materials which have a less impact. But now you can actually see that. I mean, most IC viewers don't show you this kind of material breakdown. So I can't, for example, find everything that's made out of carpet within a single click in the model. Okay, we can also see our library of types. I showed you a couple over there. For example, our types of random objects over here. We can see we've got a number of columns. We have a number of coverings as well. And this kind of starts to highlight some of the problems people actually have in their models. So for example, if I scroll down here, I can actually see that there are, if I select that and look at the bottom right, well, if I select that, you can see there's quite a number of pile caps and quite a number of, yeah, well, actually, I can't even identify a pile in this model because the piles are modeled as slabs, not as actual piles. So you can see there's lots of problems with classifications in our model. So we can do all sorts of things like coloring, filtering. I'll just color by property right now. So we can select all of the columns in our project. So all our slabs in our project, and we can say, okay, all of these are actually misclassified. All of these should not be slabs. All of these should actually be piles. And maybe they're board piles. And you can see if I hover over it, it actually tells me the description of that object straight from the IFC specification. So you can see it takes a lot of the complexity of the IFC schema and converts it into what all of us are hopefully used to in a model. So let's just reassign all of those to be piles now. Great, cool. Fix that, that's really nice. So now they have a different color. And then I guess for the really technical people in the audience, we can actually inspect to see what's inside the IFC definition itself. So if I go into the quality and coordination tab, I can actually pull this up and say, all right, you are a pile, and here's your actual definition in the IFC database. So you have these types of relationships with other objects. You have a containment relationship, you have a classification relationship, and you have a classification to a particular code over here, which is part of a uniformat system. So I can sort of navigate this hierarchical or graph-like database that IFC has. Cool. Let's make that a bit smaller. Obviously, we won't have time to demo all the features today. So I think one nifty thing I'd like to show is, especially for the more advanced users or people who are working for these larger companies who do have this in-house digital engineering capability, is the ability to run scripts directly inside. So for example, I can go and import Bonsai and get the, sorry, here we are, and get the current IFC database loaded in the project. And for example, I can get this current object which I have selected. I can say, this is the current object. And now we have our IFC pile. And I can write all sorts of scripts quite easily. So I can say, get me all of the properties of this element. And in this case, it's given me the properties as a nested dictionary, or I can say, give me all the materials of this element. In this case, it's made out of steel. Oh, steel. Okay, not concrete. Okay. Or get me the, and so let's get that material over there. And let's see if we can get any interesting properties of the steel, like the steel grade, for example. And we might not be too lucky in this case. There's no extra properties available on that steel. We can do things like find out, if this were a HVAC model, we could find out what systems they're made out of. And in this case, oh, there's one system in there. What do you know? That's pretty interesting. So let me just turn off some coloring over here. Reset the colors. And we're just going to turn off the grids. There we go. Back to this. Okay, so let's see if we can spot any systems in here. Okay, we have one system found in this project, of which, oh, I guess the cooktop is part of this unnamed system. Okay, that's not too interesting, but I guess if we did have, actually, let's do that. Let's go and open up a MEP model, and then we can take a brief glance at what do systems look like in a in IFC. So let's see here, Kobe. Okay, how about HVAC? All right, so we'll just go and quickly hide all our spaces. And the systems over here, let's see if we can see what systems they have. 31 available over systems. Let's draw the decoration. So you can see this is the connectivity diagram, which describes that this is not just a box that's nested to another box. It knows it actually has a connection point over here, which is connected to that object over here, which is connected to that object over here, and so on. It knows this part of mechanical supply error number 16. Yeah, and you can actually see these arrows here, which are pointing in the directionality of the flow. And so, yeah, I think this is things like this, which we don't normally look at our BIM models, are now possible with these types of tools. We can start really looking at smart system connectivity, which can bring us to later on. We won't have time to show this today, but under facility management, there's an integration with Brick Schema, which you can take a look at telemetry data and connecting to these kind of time series databases as well. Cool. Let's do something fun here. So let's jump back to this model over here. Turn off those grids again. They are quite in the way. Let's do a quick check on georeferencing. You can see that this project is not georeferenced. This is actually quite a fun fact. I would say that a good 90% of BIM models are not correctly georeferenced. And people who think they have georeferenced their models have not. We'll quickly throw in some random georeferencing over here. And these are just some made up numbers. And obviously this is not the right coordinate system, but just a demonstration of just how easy it is to go and edit an IFC and enhance it with more meaningful data. Now, what I'm going to do is I'm going to pull up not a text editor, and I'm going to copy paste some code here. And this is coming from the documentation of IFC OpenShell. So remember how I mentioned that everything you see here, everything you can press, everything you can run using the interface can equally well be run. Sorry, my kid has woken up. Maybe I'm speaking too loudly. Can equally well be run using code. And that's what makes all of this so exciting, that you can run this on any operating system, on the web, on the desktop, running different coding languages as well. So here are some fun code examples we can play with. I'm going to jump to this one because it looks cool. We're going to create a work schedule. And this is essentially a construction plan, which constructs the building floor by floor, starting at the lowermost floor, going up to the uppermost floor. So I'm just going to go and copy paste that code and paste it in there. And I'm just going to make one change, that rather than loading the model from a file, I am going to, over here, load this from my currently open session. Okay, and you can see at the bottom, it will save it out to model.ifc. So let's run that. Okay, it's done. So let's go and open that model. And here we are. And you can see it has retained our fixed georeferencing data. Let's turn off the grids again. And now if we go over to our costing and scheduling section, we can see we actually have a work schedule now. Hooray! And we're just going to expand this a bit, and we're going to pull out our construction tasks. It's fairly straightforward. It's just a basic script. It basically creates one line item, one task per story with a site establishment prefix. You can see this in a Gantt chart form over here. This is all live, so I can go and edit this Gantt chart, and it'll show up again in the model. This is all natively in IFC, so IFC will store the tasks and the work schedules and the resources used and the task time. You can see it's colored in red because it is part of the critical path. And now, I guess just for a bit of fun, we'll go down to animation tools. We will, actually, let's add some columns here so you can see everything is a 1 week duration. I don't think we have any calendars set up for this yet. So people are working 24/7 rather than 9 to 5 on a weekday. And let's just go and create an animation. Yeah, there we are. Fun. And obviously there's a lot more buttons and fun things to press, but yeah, I thought that might be a cool little demo. Anyway, let's pause that. And to end off, let's go and start a brand new project. Let's do a demo project. And we'll turn off the georeferencing here. And all I'm going to do is show you what it looks like to create an IFC model completely from scratch. And we are going to create a little floor plan of a little house for my pet rabbit. So I guess we'll draw a few things. So there we go. We've drawn in a bunch of walls. I've got a bunch of wall types already loaded in. So I'm drawing it with a 100 thick wall. So I can put in like a 300 thick wall over here and just go and draw over here. Oops. Or I can, let me turn on some snaps. There we go. Yep. Let's do that over there. Line that up over there. And let's throw in a door. So I've got one door already loaded in here. Maybe a door in there as well. And fantastic. Now let's draw in a floor slab. There's our slab. Go down to a top view. We'll go fillet that. So this is actually a question I get a lot. Many people think that because Blender is a mesh-based software, we're only dealing with meshes. That's not quite true. IFC has quite a large range of geometry types available. So what we're doing here is actually precision modeling with solid extrusions. In this case, it's currently using the Open Cascade kernel, for those of you who are interested in that. Great. All right. And now, just for fun, we are going to throw in a rabbit. So rabbit, of course, is furniture. There's our cute little rabbit. All right, so let's save that. And now in the drawings and documents, I am going to create a brand new drawing. So IFC can store documents, of which, for example, things like drawings and schedules. And we're going to create a plan. So IFC can also store things like annotations. So let's just make that. Let's zoom into that a little bit so we can have, oh, my door springs are clashing. Look at that. All right. So we have IFC annotation elements. We have text tags, door tags, dimensions, all the usual kind of stuff. So I'm just going to leave that alone. And let's go create this. And there we go. We have a, I mean, not the most exciting floor plan, but hopefully you get the idea. Okay, let's stop there. I think this has been a sort of sporadic crash course through various cool things we can do, both on a kind of user-friendly button clicking way, as well as a hint of the more interesting things you can delve into, no matter what your background is, very technical, non-technical, architectural, engineering, or construction. There is one more thing I'd like to point you to. YouTube. I think it's this one here. This is a link, which I'm sure we can get to circulate it later. This is a 18-minute presentation I gave 9 months ago, which includes a lot more little demonstrations of things people have done with native IFC using Bonsai. So yeah, that's it. Any questions?
Hey, Dion, so we have a couple of questions. Some people asking for, can you show the IDS?
Yes. So.
Sorry, did I interrupt the video? Sorry.
No. I'll just leave this in the
Okay.
background. I mean, just because it's more interesting than watching a blank screen. Yes. So Bonsai does support writing IDS. Currently requires code. There is no interface to create an IDS with buttons yet. Unless you are going to help create one, that'll be very exciting. But we can go and audit things. So for example, if we want to audit this model, I can jump over to quality and coordination, or use these tabs on the top. IFC tester. We can load a whole bunch of IFC files. For now, I'll just load the current one I have. We're going to generate a HTML report for it. And let's see if I have I think this is a random one I had lying around. We'll see how that one goes. And there we go. So I have now run an IDS audit against my project. Obviously, I am not passing my IDS audit. It has requirements such as, actually, let's pass it. Okay, so here we go. The project name needs to be project code, and it's telling me that it's currently named my project. So let's go and fix that. We'll select project code. And we'll go over here, jump over to project object, and we'll change project code. And it also wants the long name to be project long name. And obviously, I'm not going to go through everything there, but that's good enough for a taster. And let's rerun that. And you can see now we are doing a little bit better. We've got a few more greens where previously we had reds. Cool. Yeah, and then of course you can click on it to see all of the items which fail the requirements and so on. Yeah.
Great. Dimitrios, I'll open the mic for you. Let's see. You can activate your mic. Let's see. Okay, I'll just, there are a couple of questions. Can HVAC systems parts be defined and linked to ASHRAE tablets?
You're asking the wrong person. I have a background in architecture, not mechanical engineering, so I have no idea. Is the short answer. HVACs, you can define systems, and systems can have properties, and they can also have associations with classification systems, but ASHRAE is maybe not a classification system. It can also reference external libraries or standards. So if that's what you're referring to, if I've interpreted it right, I could be totally off the mark here. The short answer is yes, you'd create a new library and reference within that library. So I don't know, something in there. Or if, I don't know, if you're after calculation numbers, I'm struggling here. Sorry, I don't think I can give you a very good answer.
Okay, Adrian is asking if he can use Bonsai without the Blender software, as a standalone software, and if there are any extent limitations. For example, if it can be used to open and edit roads in road IFC models.
Yeah, so basically everything you see here, every button. So for example, whenever I click on something, if I just turn on the information, so whenever I go click add grids, you can see the command that is run in the background. If I go and click that and it does a thing, and I click this and I move this and then I do another thing, it's actually showing you the code it's running under the hood. And underneath that code, it has even more code, which calls IFC Open Shell. And IFC Open Shell has a huge, sophisticated API for authoring things. So if I go into the documentation, for example, and I go into, let's go into the Python API here. Sorry, by the way, the kind of short answer is yes, but you gotta know some code. So if we take a look at the API, here are all the various topics you can go and manipulate. So for example, if I wanted to look at property sets, here's how I would add a property set. It gives you an explanation. It gives you code examples you can write. So it's literally, yeah, this is all it takes to go and create a new object, add a property set, and then edit it, right? It's very straightforward. Obviously, geometry is a bit more advanced, in which case there is a detailed explanation on how you can create geometry, explaining how geometry works, how things can have multiple geometry or scale-dependent geometry, and it gives you examples of how to create different types of geometry with code, extruding profiles and things like that. Now, your question is a bit specific about roads. So in the latest IFC standard, IFC 4x3, there's a whole bunch of new geometry types introduced that capture the parametric nature of roads. And we've got actually very sophisticated implementation of this for viewing that data. However, there is currently no high-level API for editing it. So the short answer there is not unless you are ready to become a wizard in in road geometry. You can totally do it. It's just not yet packaged in such easy to use. Draw this polyline, take this circle, extrude it. It's not that. It hasn't had that higher level of simplification added onto it just yet. There is definitely no current editing interface in Bonsai for the new geometry types of road. That said, I'm making a lot of assumptions here. Like if your road has aspects of it which use existing geometry types like tessellations or extrusions, yeah, Bonsai definitely can edit those.
John, so I have two questions that are related. So they say, what is your advice to learn how to use Bonsai? And then another person asks, I'm really interested in learning Bonsai. Should I focus on learning Python programming, what would you say?
Yeah, best way to learn Bonsai is, I guess, just install it, play around in it. There are some there are some tutorials out there, but this is kind of an industry collective effort in that, and what this means is that things change very, very fast. So version to version, every 2 months there's a new version out there. And so the interface changes very quickly. New features are added very quickly, bugs get added very quickly and removed very quickly. So you will not find a lot of material out there, and things will be constantly changing. So the best place to probably go to is the open source architecture community forums, and they also have a live chat where you can reach out for help. So that's probably the best place. In the Bonsai documentation, sorry, I should have assumed this. I shouldn't have assumed this. There is kind of a intro, how to install, 15-minute tutorial, how to explore an IFC model. This will take you through the basics of the interface. Most of the interesting parts of the most kind of everybody needs them parts, how to find the classes, attributes, properties, spatial breakdown, construction types, filter materials, simple measurements. But unfortunately, after that, it's pretty slim. As for the question to whether you should learn Python, sure, why not? It doesn't hurt. IFC OpenShell and Bonsai is available in C++ and Python, and we also have an experimental compilation in WASM. So if you want to do stuff on the web as well. So imagine all of this, right? You could just copy paste what I showed you just now and then run it in a web browser and generate your, that would be cool. Unfortunately, that third option is a bit slow to run at the moment. I think what's more important is not so much the technology, but having a good foundation in your respective disciplines. So whether you have an architectural, engineering, or construction background, or operations background, have that strong, this is just a tool. The tool keep on changing, but have that really strong foundation. Understand that data is out there, and that abstractly the industry is solving. Digital engineering is about solving the data problem, having data in the first place as opposed to no data, having standardized data. So not just data that works in one system or two systems, having standardized data that internationally works. The worst thing you could possibly do is have a project standard, right? You want to have an international standard, not a project standard. Understanding the concepts of data storage. So the idea that data needs to be stored and transmitted somehow. Is it stored as a file, as a database? It doesn't matter with IFC. It can be stored as anything. And here I'm showing you partially in memory as a graph-like object, also as a file. But I work with IFC as a SQL database as well in my day job. So, and how to transmit that. So being able to exchange IFCs along a pipeline that can be enriched and have multiple disciplines connect to it. Don't just have a model from the architect and that's it. We can do, and we should be doing so much more with these. We should be connecting costing. We should be connecting risk and quality. We should be connecting carbon. We should be connecting construction timelines. We should be connecting engineering or building physics. We should be able to do visualizations direct from the model. So all these things are ways we should really be pushing the industry to do more. And that's where, that's what I would advise. Like, don't just say, I got to learn a tool, or like, I got to learn Bonsai, or I got to learn Python, or any tool for that matter. Like, just see what's out there. I mean, if you take a look at the efforts done that started in the 1990s, it's been an incredible mammoth task by some very, very smart people. You can see on this appendix over here, this is the list. You can think of this as a dictionary of every single concept that is relevant to us in the building industry. You know, it's got every, like some of these, like a work order approval, for example, or a cost value. Here are some road geometry types of geometry objects, or some of the structural engineers will start to recognize these boundary conditions. Some of the GIS people will start to understand these types of coordinate operations. Like, I haven't even scrolled down. The facility management guys will start to understand the different types of actors, you know, the warranty providers, the suppliers, the manufacturers. And I haven't even scrolled down. Like, you notice you don't see wall on my screen, or slab, or door, or window on my screen, because this is the sheer diversity of rich semantic objects that a computer can understand about our built environment. It's not just, this is a wall, it looks like a box, and it's got a fire, you know. Yeah. Understanding this big dictionary that people have been working on from the 1990s, and not just this dictionary, but how to combine them. So, for example, this chapter describes how to go and connect these various dictionary, these nouns with verbs, that you can create sentences to describe things like, this is a fairly basic one, you know, this object, like this wall, is part of this group. So this air handler is part of an air conditioning system. You know, you can start to create sentences, and fairly sophisticated ones. Yeah, to describe our environment. And I think that is really important, that to understand the concept and really take a crucial look at the data that we have, and you know, look at it critically. Do we really have that many piles in this? Like, the average model that comes through, the moment you dig past its surface and go, yeah, that looks like a building, you realize the number of holes in it. You know, can you in one click isolate everything that's concrete? Probably not, because it hasn't been properly standardized, as an example. Sorry, I sort of branched off a bit there.
No, it's okay. Dion, Max is asking, is there something to consider if I want to build an add-on or add tabs to Bonsai for my own automation process?
Sorry, what was the question? Like, what was there something to
Is
consider?
there something to consider if I want to build an add-on or add tabs to Bonsai for my own automation processes?
I don't think there's anything to consider. Just go do it. I mean, yeah, I mean, I've done it. So I actually, oh, it's not here right now on this particular version. But yeah, I've got a whole bunch of, you know, specific workflows that are just individually mine, or I've rolled out at my company. I can tell you, on those large mega projects that I mentioned earlier, they all have specific functionality built just for their needs. And yeah, so go ahead, do it. Nothing's stopping you. Or you don't need to use Blender or Bonsai at all. You can just run it as a script on a server. So, I mean, this is 2024, right? The moment somebody submits a model to you, it should go through an automated processing system. It should be instantly audited and enhanced and improved and correlated, and alerts pinged on other people's desktops going, hey, this wall has changed. Have you checked your cost plan lately? You know, it should be doing all those types of things. So yes, build all that stuff. Don't wait, build it.
Okay, yeah, which is one from Ada or Ada. She's asking, is there are plans about integrating Bonsai BIM in the geometry nodes in Blender, or if that would be even possible in the future?
Yeah, so this is a really interesting topic. So short answer, yes, but currently other priorities. So not happening in the next week. The reason is that IFC describes as an international standardized level, you know, or attempts to describe everything in our built environment. However, because it is an international standard, that is both a strength and a weakness. The strength is that the basics are standardized. The weakness is that it, on purpose, does not cover things like individual systems or applications, or highly parametric design like geometry nodes. For those of you who don't know what geometry nodes are in the audience, it is a node based, if you've used Dynamo or Sverjoc or Grasshopper before, it's like that, but in Blender. And therefore, if you do build something in one of those systems, no matter what system it is, you will not store that in IFC. That data will be lost in IFC. And it is out of scope of IFC to store that. So it will never be stored in IFC. But IFC can certainly reference it. So it can say, by the way, this wall was created parametrically by a closed external system, and it can reference it. And then and then 90% of viewers will look at it and go, uh-oh, it's some closed external system. I don't know how to touch it. But that 10% who are set up in such a way that they can consume geometry nodes external systems, such as Blender users, will be able to edit it. So let me show you that with a picture. So let's say I want to create a roof. Roof. Okay, so here's the roof. And you can see I am parametrically editing this roof. All right, so IFC does not encode rules about this roof I have just generated. IFC just knows that it's a roof and it has this geometry. It doesn't know that I can edit it and automatically generate this type of ridge and angle and so on. It doesn't have that parametric understanding, and it won't, and it shouldn't. And this particular algorithm is known as a straight skeleton, and it's one of many, many ways you can generate a roof. And so we just state that in this case, here's a really dumb way of doing it. In a property, we can say, here is the underlying data that generates that roof. And anybody who can consume that data, this is simple JSON, can go and regenerate that roof from the profile that we store using the mathematical rules of a straight skeleton. And it's no different with geometry nodes. We will simply have to come up with a convention for geometry nodes. This is not something IFC will go and dictate. It will merely state, it will give you a way to reference an external system or external material shader or just some sort of external thing. And then we will have to come up with a convention that says, okay, for geometry nodes, this is the way that we reference it in a standardized way, store it in external files and so on, that it can be linked and so on. So that's the strategy of how you do it. So it can be done, but as an externally referenced system to IFC.
Great. I'll just take two more questions because it's really late there. So Ahmed is saying, shall civil engineers who are working on infrastructure projects like irrigation roads learn this program?
Yeah, I don't see why not. I mean, the concepts of interrogating the data are the same everywhere. And if anything, you'll probably get a much better understanding of georeferencing when you have to integrate with vertical construction. So running IDS is definitely very applicable in the civil space. I actually was just working with someone earlier to generate borehole data. So that's definitely applicable. So we wrote a little script that would generate boreholes in IFC. Patching up files. So automatically fixing things in files or injecting new data into files. So definitely something you can use it for. Doing clash detection, doing data dumps out of it. So like that borehole thing, right? If you wanted to go and schedule out all those boreholes with coordinates and types of soil, for example, you can definitely do that. Costing and scheduling still applies to the civil world. There's no difference there. Facility management is slightly different. Systems like the Kobe 2.4 standard probably doesn't apply at all. You'll probably use something different there, but not too different. Like it's still, there are similarities which you can build into there. Yeah, I mean, injecting new annotations is definitely something that can be done. And of course, the first three, general slicing and dicing and viewing of project information is always applicable.
Great. So I'll address the last question, Stephen Barrett's question. So he's talking about the carbon footprints, basically that investors need to know the projected carbon footprint of buildings they may invest in. So can embodied carbon of each material be added into the materials in an IFC model for easy summing up of a carbon, similar to costs, and how to do that?
Yeah. So again, that's a big question. Answer is yes, you can, but it's there's many steps to doing it, right? The very first step is you actually have to be able to identify objects. Well, actually, it depends on the project phase, right? At certain project phases, you might not do an elemental breakdown. You might just go through square meterage, right? You might just go through, I have this amount of floor area based off benchmarks. This is my carbon, and that's it. So you're not actually looking at objects. You're looking at spaces. But let's say you are progressing and you do know your individual objects and you're counting them. You then need to know what material they're made out of. So yes, IFC can obviously store the type of material. The example I showed you just then of that Revit model had very poor material data. I couldn't tell the type of steel that was, for the steel grade. I couldn't tell, for example, the compressive strength of the concrete. I couldn't tell how much Rio, the density of Rio is in that concrete. But IFC does have capabilities to do all this stuff. So for example, I can have, for example, in situ, blah, 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 blah. I can have a material in here, and that can have data, for example. I have to check what version I'm on to here, but I can go and assign the compressive strength of that, whether it's in situ or precast. The strength class of the concrete, and only once you know all that data, then you can associate an appropriate unitized carbon equivalent value to it, ideally from some database somewhere, in which case you'd link to it, the EPD using that document reference I hinted at earlier, and you would store, you can see here there's two here. This is the first one you do, this kind of environmental impact indicator. This is the per unit, unitized ones. This is the typical one. So whatever it is, climate change per unit. And you can see the life cycle phase. So typically, this would just be the manufacture of it's just material, the material data. And then from that, you would also specify the functional unit reference. And so you would specify, is this per unit weight? Is this per unit volume, et cetera, et cetera, et cetera. So let's say once you specified that and you quantified this guy, which we haven't got any quantifications for, but let's, yeah, we can run a quantity takeoff on this. Yeah, I'm getting a bit ahead of myself here. Yeah, you do your quantity takeoff. You'd then go and actually this is a roof, so roof, I'm not sure whether you do that. You do area, I think. Anyway, yeah, you'd throw that in there, then you'd be able to get, you'd multiply that, and then you would get your final climate change value, which is the unit multiplied by the quantity. And then, yeah, I guess you'd schedule it all out, and with a few ways to break it down. So yes, obviously crash course in carbon counting there, and a lot of details missed, but yes. And yeah, I do it, I guess.
Okay, so thank you very much, everybody. Sorry if we can address all the questions, but please, if you have any more questions, just drop us an email. If you're interested in parametric design, check out our course. You can put your details there, talk to our admissions department if there are any doubts, or if you are interested in learning these programs. So I encourage you to do that. Thank you very much. Thank you, Dion, for your demo. I know it's very late over there, so thanks again. And as I say, remember that everybody's going to receive the recording of this masterclass via email. Okay. So, I mean, that's all. Thank you very much. And thank you, Dion.